Hi guys, welcome to this last minute revision on D and F block elements, okay, for your upcoming HSC exam. Now, what exactly are you going to study in this particular topic? Now, this D and F block element has two sections. First is the D block, and then you have the F block, wherein you have lanthanides a little bit bigger and actinides very short. Okay, so in the section on D block, it is a little bit lengthier because you have the properties, right? You have the periodic trends, you have the preparation of potassium dichromate and potassium permanganate, right? And in F block, you have, and even the structures of all these, right? And in F block, you have electronic configuration and lanthanoid contraction, that is nuclear charge increases by 1, atomic number increases by 1 unit, nuclear electrons are added, right, in the F subshell. So due to the poor shielding, basically there is size contraction. Then the consequences are decrease in basicity and the formation of chemical twins, right? So and then you have actinides, difference between lanthanides and actinides and how exactly they are different. And in all this D and F block, you are supposed to do the oxidation state as well. Okay, let's have a look at what exactly are the important parts. Okay, so let me begin. Okay, so in the case of D block elements, what are you going to do? You should do the properties, right? Outermost electron enters which subshell, their general electronic configuration, their color, different, unpaired electrons are many, so basically they form very strong metallic bonds. Correct. And then configuration of copper and chromium, the extra stability, the structure of dichromate, chromate, permanganate and dimanganate. This is something that you should do it. Now, when it comes to preparation, if you can, you should do it. If you have already done the metallurgy topic very nicely, then it would not be difficult for you, right? Now, even if you're not able to do for dichromate, at least in the case of potassium permanganate, it's pretty much simple, right? So it's anyway your call how you're going to do it. And the reactions, most of the reactions you have already studied in the organic section, but the oxidizing reducing action that you're supposed to do, then properties color due to DD transition, catalytic property due to, or they contain almost similar size, right? So they can replace, they have very big catalytic surface. Now one metal can replace another metal because they are almost similar size, so they form alloys and interstitial compounds, that is hydrides basically, right? So these are little bit important, they are easy to understand, so I would recommend that do not leave this. Okay, then you have the F block. Now in the case of F block, basically you have the lanthanides, right? If you remember the trend, well and good. Remember the properties, the general electronic configuration. Now which electron enters where, which are the elements that show extra stable configuration, and the ones which have very good oxidation states, right? And then you have lanthanides contraction. In the case of lanthanides, electrons atomic number increases by 1 unit, right? Poor shielding effect comes into picture. This leads to size contraction, and the consequences is decreasing basicity of lanthanum hydroxides, right? And the chemical twins, you have molybdenum tungsten technetium rhenium, and then you have niobium tantalum and so on. Now please remember this very important chemical twins, okay? And even they can be asked in MCQs as well. Difference between lanthanides and actinides, right? Actinides are radioactive, lanthanides are not. And then few synthetic, few natural, and then decreasing basicity, less, and then you have less lanthanoid contraction, more lanthanoid contraction. I think it's pretty much evident. It is straight away given in the textbook, so do not miss this. Now, important thing, MCQs on oxidation state. Now, general oxidation state, specific oxidation state, please do not miss this. Okay, so this was about the F block elements. Now the next is actinides. As I've already said, differences between lanthanides and actinides, right? And their position in the periodic table as well, right? And then you have electronic configuration and then the oxidation state, right? So most important part is the difference between lanthanides and actinides, right? But there could be a lot of questions related to electronic configuration. I think I made a spelling mistake. It should be electronic configuration over here. Okay, anyway, that's fine. So this was about the section on lanthanides and actinides. Okay, so I hope you find this session useful. Now, since this is a very simple last minute revision, so it has to be very immediate, and which it has to be quick. And this is not meant to supplement your, this is not meant to give certain different thing to your studies. It is just going to add or give a supplement to your preparation. So after all, you are supposed to prepare the entire topic, that is for sure, but these are the things which you should never ever miss. Okay, I wish you good luck, and the next just stay tuned for the next last minute revision videos. Thank you.